What if you could run a giant AI model at a fraction of the time and get back the exact same answer? Not close. Identical. Every token. Not a smaller model, not a compressed model. The same output, just a lot faster. It's called speculative decoding, and it's about as close to a free lunch as machine learning ever gets. Let me show you how it works, and then prove it. Here's the problem it solves. A language model writes one token at a time. It predicts a token, feeds it back in, predicts the next one, and waits. Every step depends on the step before it. It is strictly sequential. And the slow part isn't the math. It's memory. Loading those billions of parameters for one single token costs almost as much as loading them to check 5 tokens at once. So here's the trick. You bring in a second, much smaller model, the draft model. It's cheap and fast, but not as smart. The little draft model raises ahead and guesses the next several tokens entirely on its own. Then, the big model, the target, checks that entire guess in one single pass, instead of generating one token at a time. For each guess token, the big model asks one question. Is this what I would have written here? Every token that matches is accepted, for free. At the first token that doesn't match, the big model overrules it, throws away the rest of the guess, and the loop starts again from there. When the draft guesses well, one expensive pass hands you 4 or 5 finished tokens instead of one. And this is the part that makes it a free lunch. The big model has the final say on every single token that gets kept. So the output is byte-for-byte identical to running the big model alone. You are not trading away any quality for the speed, none. Now, I didn't want to just tell you that, so I built it. A tiny simulation with a real fast draft model and a real slow target model. Same prompt, run 2 ways. The speculative output matched the baseline exactly, character for character, and about 65% of the draft's guesses were accepted. 600 slow passes through the big model dropped to 168. 2.5 times fewer trips through the expensive network for the identical text. But there's a knob you have to tune. How many tokens the draft guesses before each check? Guess too few, and you barely save anything. Guess too many, and the big model rejects the tail, and you've burned the draft's work for nothing. In my test, the sweet spot was around 6 tokens, about 3 times faster. And this isn't a research toy. It ships today in the production engines that serve large models. It's one of the big reasons fast AI endpoints actually feel fast. The one catch. The draft has to agree with the big model most of the time. A bad draft just adds wasted work. Never wrong answers, only lost speed. Same output, fewer slow steps, 0 quality lost. That is the closest thing to free this field has. If that's the kind of under-the-hood breakdown you want, subscribe. I go deep on how these systems actually work.